The following scene will allow you to better understand elliptical filtering. In this scene, I've created a very high resolution texture made of circles. Those circles can be seen as being the actual pixel that is going to be rendered in the final image. Why I'm using circles is because the actual elliptical filtering uses ellipse in order to do the actual image lookup. So that's why I've been using these circles to better illustrate how it's going to do the actual lookup. So what I've done here is I've taken this particular texture here and use it as a camera projection. So whenever I render here, I get this this very repeated circle patterns that's been projected onto the surface. Although they look pretty flat and pretty evenly distributed, but actually when you render it over on the object, you'll see that the actual these textures or these circles are being projected from the camera. If we start to actually zoom in on some of these triangles, you'll see some of these circles. You see that these circles will eventually become ellipses that covers a certain part of the object. So that is, let's say for example, a given pixel has been rendered in the image right here, and we take this given pixel here and we try to actually represent it onto the actual surface being rendered. Then you see the actual pixel gets slanted slightly depending on the field of view, and also have this ellipse form. Normally a standard bilinear lookup would only look at the given location. In this case, in order to filter, what is going to happen for elliptical filtering is going to actually look up inside the actual ellipse, and all the pixel contained inside the ellipse will contribute to the final pixel being returned during the elliptical lookup. So as you can see here, we see these this very patterns here. As we zoom in, obviously we see this very elongated circles being projected. Let's go back here and show you a little bit what this format means actually. Whenever you are using elliptical filtering, it is strongly suggested that you actually provide the image into what we call pyramidal format. So basically, whenever you use IMF copy, IMF underscore copy dash P, it stands for pyramidal. It's during the actual conversion to memory map file, it's going to actually lay out a multi-resolution file format in memory such that the actual ellipse lookup can look at different resolution. So for example, let's say we do have a 1K texture, so it's going to look like this in memory. So pretty much we have the RGB channels being laid out like this, and the extra space here is being used for all the other levels. So we have the RGB here, this is a quarter, half resolution, and then we have a quarter resolution, so on and so forth, until the actual resolution becomes a pixel, 1 by 1 pixel. So this layout allows to have in a single file format or a single image multiple resolution. So depending on how the ellipse is being projected and how much pixel is going to cover, the elliptical filtering will look up in either of these resolution depending on the size of the ellipse. If the ellipse contains is basically overlapping the entire image, for example, then obviously if you do have an ellipse in that space, it will have to look up many pixels to be able to figure out a unique color for the entire ellipse surface. Then obviously in this case, the larger the ellipse cover in terms of inside the image, then obviously it will look higher in the actual resolution to speed up the process. So in this case, if the ellipse is really large like this, chances are that we'll start to look in these resolution or these resolution because it's much quicker.